Hi everyone, this is lesson 12.4, probability of disjoint and overlapping events. If you are an in-person learner, you don't need to watch this video because we're going to do this lesson in class today. So this lesson, we're going over the addition rule, which is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So we're going to learn about this rule, what it means and how to use it. This is actually an equation that will be provided to you on your formula sheet for the air test. So you actually don't have to memorize this, which is nice. So when you consider all outcomes of either of two events, A and B, you form the union of A and B. When you consider only the outcomes shared by both A and B, you form the intersection of A and B. All right, so pause for a second. So consider all of the outcomes. So the union of two events is like when I was a student, my teacher gave us an example of like two people getting married. They form like a marriage union. So you got all of your stuff and you've got all of somebody else's stuff. And some things overlap, like you share some things in common, but some things you don't have in common. But you include all of it. So this diagram here represents the union of A and B. So we call that, when we were working with probability, we call that the probability of A or B. So either A or B is all of A and all of B, or all of B, which includes both. Now, remember, if you're taking all of A and then you take all of B, if you add those two together, you're actually adding the middle part twice. Okay, more on that later. When you consider only the outcomes shared by both A and B, you're looking at where they intersect. So you're just looking at this red part in the middle. So that would be the intersection of A and B, which we call in probability the probability of A and B. So both A and B, or you can say both A and B. And then the union intersection of two events is called a compound event. You have two or more events. We've been working with compound events throughout this whole unit, which, by the way, you won't have a quiz over 12.2 and 3 because since those aren't on the air test, I decided to just continue past those lessons and not come back to them to do a quiz, so we could just focus on the material that will be on your test since it's coming up soon. So back what I was saying, so if you were to take the probability of A and add the probability of B to get the probability of A or B, you're actually adding their intersection twice. So when you calculate the probability of A or B, you have to subtract out the probability of A and B once. So this part right here is the probability, well, I guess I already said it, is the probability of A and B. So here is our formula for if A and B are two events, then the probability of A or B is that right there. So that's how you would write it. And then let's say, and I think this is on the next slide here at the bottom, or where did this part go? Oh, I see, it's down here. So if two events are called overlapping, I thought there was more to the notes, if they have one or more outcomes in common. So these two would be overlapping, as shown in the first diagram. Two events are disjoint or mutually exclusive if they have no outcomes in common, as shown in the third diagram. So the third diagram represents if A and B are disjoint, or we say mutually exclusive. Means the same thing, exclusive. So in this case, the probability of A or B is just the probability of A plus the probability of B, because the probability of A and B happening at the same time is 0. So actually our little formula here works for both equations, because when you get to disjoint events, this part is just going to cancel. So this probability of A and B is 0, so then you just add them together if they don't have anything in common, or if they can't happen at the same time. So let's do some examples. So find a probability of disjoint events. Card is randomly selected from a deck of 52 cards. What is the probability it is a 10 or a face card? So in case you're not too familiar with a deck of cards that's 52, here's how it works. So you've got 4 different suits. You've got hearts. Actually, I'm going to color code here. You've got hearts and diamonds. All of hearts and all of diamonds are both red. And then you have spade, the spade suit, and you have the club suit. And those are both black. They have little symbols that you can look up if you're not familiar. But then with each suit has 13 cards. They go from 2 to 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it goes a jack, a queen, a king, and an ace. So each of these different suits has 13 cards, so 13 times 4 gives you 52 cards, right? And then it has the same types for each. Okay, and all of these are red, all these are red, all these are black, all these are black. So it says, what is the probability that it is a 10 or a face card? So we want the probability that it's 10 or face. So we're going to take the probability of it being 10 plus the probability of it being a face, and then minus the probability of both things happening at the same time. So the probability that it could be a 10, well, if you have 4 10s, one for each suit, then that would be 4 out of 52. And then plus the probability that it's a face card, which if you have jack, the face cards are jack, queen, and king. They have faces on them. And so that would be 3. 3 times 4 gives you 12, so that would be 12 out of 52. And then minus the probability of a 10 or a face card happening at the same time. Well, you can't have a 10 and a face card happening at the same time, so actually this would just be 0. So really we're just adding the probability of 10 plus the probability of face, which equals 16 over 52, which simplifies to 4 over 13. So really, you also just could have looked at, okay, we have 4 here out of 13. And then if you multiply by 4, you just simplify it anyways. And then a 6-sided die is rolled. What is the probability that a number is rolled is less than 3 or greater than 5? So we would have 1, 2, 3, 4, 5, 6. So we want the probability less than 3 plus the probability of it being greater than 5. And we're not going to subtract the probability that both happen because they both can't happen at the same time. So the probability of it being less than 3, well, you could have 1 or 2, so that'd be 2 over 6. Plus the probability of it being greater than 5, that would just be the 6, so that would be 1 over 6 is 3 over 6, which is just 1/2. And then the reason why these two events are disjoint is because they both can't happen at the same time. So A and B cannot happen at the same time. Okay, a few more examples. Card is randomly selected from a standard deck of 52 cards. What is the probability that it is a face card or a spade card? So we'll do the probability of it being a face card plus the probability of it being a spade minus the probability that it's both. So the probability of it being a face card, remember, was 12 out of 52. The probability of being spade, well, if you a quarter of them are spades because it splits it up into 4 different types of cards. So that would be 1/4, or you could say 13 over 52. And then minus the probability of both of them happening. I'm going to go back here to look. So if it's both it's asking for a face or a spade, a face and a spade. So here's your spades, and you've only have 3 out of all 52 cards. So that would be subtracting 3 out of 52. Okay, so this is why I kind of like to have the same denominator just so I can do the math in my head. So this would be 25 minus 3 is 22 over 52, which simplifies to 11 over 26. So B would be our answer. Okay, and then a 6-sided die is rolled. What is the probability of rolling a number greater than 4 or even? So once again, 1, 2, 3, 4, 5, 6. The probability of it being greater than 4 plus the probability of being even minus the probability of both. So probability of it being greater than 4 would be 5 and 6, so 2/6, plus the probability of it being even, which would be 3/6, because it's 1/2 of them are even, minus the probability of both happening. So out of the 5 and 6 from greater than 4, only 6 was even, so that would be just 1 over 6. So this would give us 4/6, which is 2/3. So C. All right, and then here's some more examples. Out of 200 students in a senior class, 11 students are either varsity or on the honor roll. So I'm going to say the probability of varsity or honor roll is equal to 113 over 200. And then it says the probability, there are 74 seniors who are varsity athletes, so the probability of being varsity would be 74 out of 200. And the probability of being on the honor roll is 51 out of 200. But remember that there are students who could be both. So these two don't add up to 113. And that's how you know that there are students who are both. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So then this equation would go 113 over 200 equals 74 over 200 plus 51 over 200 minus the probability of both. So I would add up 74 and 51 and subtract it from 113. You do that on your calculator, you get 12 out of 200. So there are 12 people who do both, and that gives us 0.06 or 6%. All right, and then a similar question, suppose 32 out of the 200 seniors are in a band. So the probability of being in band is 32 out of 200. 64 are in band or on the honor roll. So the probability of band or honor roll is 64 out of 200. What's the probability that a randomly selected is in both? So kind of the same thing. Do 64 out of 200 equals 32 out of 200 plus the honor roll kids, which was 51 out of 200, minus the probability of both. So add up 32 and 51 and subtract it from 64, and you get 19 out of 200, which is 0.095 or 9.5%. All right, and then a very similar example, I'll let you guys try this one yourself. 200 students surveyed, 92 owned either a car or a computer. So the probability of car or computer is 92 out of 100. And then the probability of owning a car is 65 over 200. The probability of owning a computer would be 82 out of 200. So there are a lot of kids who own both. So once again, you would just add up these two and subtract them from 92, and you get 55 out of 100, which is 55%. Okay, a complement. So I've kind of already talked about complements in the previous lesson, but it's notated as a bar. It's called a complement, and it consists of all of the outcomes that are not in A. A little trick is if it's something is asking you to find the probability of at least 2, then you would do the complement of, then to find that, you would find the complement of none of them. So you would do 1 minus the probability of none. So that's a little trick that we'll learn for a different question, or we'll use. All right, so here's how you would notate it. The probability of A complement is 1 minus the probability of A, because it's like 100% minus the probability of A's percent. Okay, so here we have probability of 2 die. So it's talking about the sum of the 2 die. So it's nice to have it all laid out. So you're looking for, you're asking for the probability that the sum is not 6, that the sum is less than or equal to 9. So which ones are 6 and 9 and whatever? So this would be 2. This actually goes in a nice pattern. This would be 2, 3, 4, 5, 6, 7. And then this would be 3. Right, this is a 3, 4, 5, 6, 7, 8. I'll choose a different color. This would be 4. 3 plus 1 is 4. 5, 6, 7, 8, 9. 4 plus 1 is 5. 6, 7, 8, 9, 10. You see the pattern that this is making. And then 7, 8, 9, 10, 11, 12. Also, there's a couple questions on the edge elastic where you might want to refer back to this diagram because it asks about the probability of the sum of rolling 2 die. So the probability that the sum is not 6. Well, how about you can add up all the ones that are at 6, or you can take 1 minus the probability that the sum is 6. So if I count them, I count 1, 2, 3, 4, 5. So 5 out of, and the total is 36, right? Because you do 6 times 6. So 5 out of 36 would be 31 out of 36. And then the sum is less than or equal to 9. So here's 9, less than or equal to. And how about what might be easier to count is the sum that is greater than 9. So that would be 1, 2, 3, 4, 5, 6. So we'll do 1 minus 6 over 36, which is just 30 over 36, which is 5/6. And then a card is drawn from a deck of 52 cards. Find the probability that the card is not a 7. So how about we'll do the complement of that. So 1 minus the probability that it is a 7. How many 7s are in a deck of cards? Well, 4. So I'm doing 1 minus 4 out of 52, which is 52 out of 52 minus 4 out of 52. So we get 48 out of 52. Which is 12 over 13 if you simplify. Or you could just do 12 over 13 because there's 1 per suit, then that would be 12 out of 13. And then the card is not a red face card. So let me go back and look. So the card is not a red face card. So how many face cards are red? That's the question. So here are the red cards. And then you've got 3 for hearts and 3 for diamonds. So that would be 6 out of 52. So really we're doing 1 minus 6 out of 52, which would be 6 minus 52 is 46 out of 52, which simplifies to 23 out of 26. You divide both of these by 2. Okay, and let's do a little bit of a complicated situation involving permutations. I will put these on tests and quizzes as bonus, but I'm not going to put it as like a question that counts. So this is a restaurant gives a free fortune cookie to every guest. The restaurant claims to have 500 different messages hidden inside the fortune cookies. What is the probability that a group of 5 people receive at least 2 fortune cookies with the same message? So remember what I said about at least 2. So instead of doing at least 2, we're going to do 1 minus, then we're going to do the complement, 1 minus the probability of none, or that nobody receives the same message. So we'll say all are different. Because that's going to be easier to find. So first of all, we'll need the denominator. So the denominator will be the probability of all of the different ways that 5 people could get 500 different messages or 500 messages, whether they're the same or not. So the way to find that number is you take 500 and multiply it by 500 5 times because of the multiplication rule. But instead of doing that, we could just do 500 to the 5th power, because that's the same thing as 500 times 500 times 500 5 times. So the denominator will be 500 to the 5th power. That's all the different ways that we could give a group of 5 people fortune cookies from 500 different messages, whether they're the same or not. Doesn't matter, regardless of they're the same. Now we want to know how many of those would all be different. So now you're talking about permutations. So now you want, in the order, the order here does matter, so we're going to use permutations. So we're going to do the permutation of 500 if you have 5 people. So if you type that into your calculator, you'll get 0.0199. So that'd be like 1.99%. Okay, so very, very slim chance that could happen. But at least 2 cookies with the same message. Okay, and then part B is really similar to that. So there are 100 people at a dinner party. What is the probability that at least 2 people have the same birthday? So now you've got the 10 people, kind of like the 5 people, but what's the total? Remember how there was a 500 in the other example? So what's the big number that we have here? And the answer to this is the days of the year. So it's 365. That's kind of like the hidden part of this question that's not in the question. So if you have 365, kind of like you had 500 fortune messages to choose from, here you have 365 days to choose from. So this is going to be a really similar example because it says at least 2. So to find at least 2, we're going to do 1 minus the complement. So 1 minus 365, and then to the 10th power, and then divide that from 365 with a permutation of 10. And now don't go and do like 365 P10 and 365 to the 10th power in your calculator separately, because they're going to be huge numbers. Just type this all into your calculator at once. Maybe use the fraction button for this part, and then you would get 0.117, which is 11.7%. So a little more likely for something like that to happen. Okay, so that is the end of this lesson, and tomorrow you will have an Edulastic assignment going over this, but I am actually going to open it up earlier so that people who are going on vacation on Friday can do it ahead of time. All right, so hope you enjoyed this lesson. Have a great weekend, a great spring break if I don't see you before then.